Alright guys, here's the 2.3 absolute value inequalities. For you that need help with your worksheet 2.3, and I'm going to do a few questions for you, question number 9, 10, and 13. So remember in class, we made these little flashcards right here. We made absolute value inequalities in class. One for a greater than case, our greater, and one for a less than case, okay? So this helps us keep track of what we need to do, but hopefully you're going to stop, after doing your homework, you're going to stop using these flashcards. I don't want this to become a crutch. I just want you to organize your information, but eventually stop using it, okay? So I'm going to put on the side here if I need to look at it, but hopefully you will not need to use it as we're doing our homework. So I'm going to do question number 9 first. So question number 9 says, we have, in your worksheet, we have 2 times the absolute value of the quantity 7 minus 2x minus a 1, and all these things here on the left is less than or equal to 37. So first, my very first thing that I always must do is to isolate my absolute value. Whatever is inside of absolute value, my absolute value needs to be isolated. And in order to do that, we will use order of operations, right? So first we need to take care of order of operation is our PEMDAS, okay? So first I'm going to use subtraction or addition, whatever comes first. This is a 2 times the absolute value. It's a multiplication. And then here I have a minus 1. So the first thing I'm going to do is add 1 to both sides, and we end up with 2 times the absolute value of 7 minus 2x, and that is less than or equal to 36. So I took care of addition or subtraction, whatever came first. In this case was an addition. Now I'm ready to do division or multiplication. Well, in this case I have a 2 times the absolute value. So the reverse of multiplying is dividing by 2. So I'm going to divide by 2 here, divide by 2 here. So now this becomes 1 times the absolute value. So I just have the absolute value minus 2x. Okay, the invisible one does not have to be written. And because I didn't divide by a negative, I divided by a positive, then I'm okay. The inequality stays the same, and 36 divided by 2 is 18. Okay? So I successfully did my first step, which was isolate the absolute value using the order of operations backwards. Now the second thing, now I can use the definition of the absolute value function. Okay? Now I can use the definition of absolute value function that says once you have an absolute value of a quantity and is less than or equal to or greater than or equal to a constant, we may remove the expression and create 7 minus 2x is less than or equal to 18. This is a less than case, so it's an and case. And then negative 1 times the quantity of 7 minus 2x is less than or equal to 18. Okay? I don't need to look at my cards anymore because I've been doing this for so long, and I just look for the words that make sense to me. Is a less than. I did not divide by a negative, so I'm okay. And the definition is to take the expression out and take the negative version of the expression out. Okay? Now from here, we just need to solve it, again, using PEMDAS backwards. Every time we're solving for a variable or isolating a certain item, is always order of operations backwards. So now I'm going to subtract the 7, is always addition or subtraction first. Subtract the 7. And then here we go. 7 minus 7 is 0. We get our negative 2x by itself. And then I have is less than or equal to 11. Okay? Now I'm going to divide by a negative 2 on my left and on my right. Uh-oh, there's a division by a negative. Let me go ahead and switch the sign already so I don't forget. So negative 2 divided by negative 2, it's a 1, and 1 times x is just an x. And then here we have negative 11 divided by 2, and it's okay. I know it's not a really pretty number, but it is a real number, and that is okay. So I want all the x values that are greater or equal to negative 11 over 2. Okay? And I also want, okay, let me separate this over here. I also want this other side over here. I'm going to divide by a negative and divide by a negative on the right. Immediately, before I forget, let me switch my inequality, flip the inequality. And negative 1 divided by negative 1 is just a 1 times my quantity of 7 minus 2x. Okay? And positive 18 divided by a negative 1 is negative 18. Okay? And then I look at this and I say, 7 minus 2x is greater than or equal to negative 18. I can keep going on my solution here. Subtract 7, subtract 7. 7 minus 7 is 0, and 0 minus 2x is just a negative 2x. It's greater than or equal to my negative 18, 19, 20, that's 20, 18, 19, 20, 26, nope, 25, sorry, 25, there we go, negative 25. Then we divide by a negative 2 right here, divide by a negative 2 right here as well, okay, on both sides. Negative 2 divided by negative 2 becomes a 1, and 1 times x is x. I divided by a negative again. Immediately I need to switch my inequality. So now it's less than, okay? Now it's less than. And negative 25 divided by negative 2 is a positive 25 divided by 2. If you want to write 12.5, x is less than or equal to 12.5. That is okay with me. So I have an AND case. I have two values. They're fractions, but they are between. If you want to simplify this, x is greater than or equal to negative 5.5. So if you want both decimals, it's easier to see on a number line. Okay? If I was to draw my number line right here, so I can show you the solutions on a number line, we would have a 0 in the middle. We always got to put the origin so we have an idea of where things are. My negative 5.5 is on the left side, negative 5.5. It's equal, so I'm going to put a closed dot. And I want all the x values that are greater than that negative 5.5. But I also want all the x values that are less than 12.5. I'm going to put 12.5 right here. Because it's equal, I'll put a solid dot, and I will put all the values that are less than. And sure enough, we have an AND case, and the graph should look exactly what we said it would be, an AND case, okay? So there we go. And hopefully this helps to see how we did this. Let's do another problem. Let's do number 10. Okay, so number 10 here says we have the absolute value of this quantity 1/7 x plus 2 minus 5 is greater, I like to say greater, so I remember is an OR case, greater than 3. So an OR case, the graph should point out this way, okay? So I at least have an idea of what the graph will look like, all right? So I'm going to use order of operations so I can isolate the absolute value. That is always the first step, is to isolate. So I'm going to add 5 and add 5 to both sides. I end up getting my absolute value of 1/7 times x plus 2, and that is greater than 8. Now my absolute value is all alone, all isolated, there's nothing around it. Now I can use the definition of absolute value. It tells me I can take the expression out and set as two separate equations. 1/7 x plus 2 is greater than 8, or the negative quantity 1/7 x plus 2 is greater than 8. Okay? Then I'm ready to solve it. I'm going to subtract 2 from both sides here. It's always subtraction first. And then we get 1/7 x is greater than 6. To get rid of a denominator or a fraction, I multiply by the reciprocal. So I'm going to multiply by 7 over 1, that's the reciprocal. And same thing as just 7, I'm going to multiply by 7 over 1 here, or just 7. Okay, this is going to become a 1, because that's going to become 7 divided by 7. And 1 times x is just x, and that is greater than 42. Okay. So there we go. We want all the values that are greater than 42. Over here, the very first step, as always, if you see, is always the same step, divided by -1 first. The moment I divide it by -1, before I forget, let me go ahead and flip my sign. So now I have a 1/7 x plus a 2 is less than a -8. We're going to subtract the 2 just like we did in this case. Subtract the 2 on both sides. And I get my 1/7 x is less than a -10. Multiply by the reciprocal just like we did here. The steps stay very, very similar, almost the same. So I'm going to multiply by a 7 over 1, the reciprocal. Multiply by a 7 over 1, also on the other side. So this becomes a 1, and 1 times x is x, is less than a -70. -10 times a 7 is -70. So if I am drawing my number line, here's my number line to show the solutions. I always have my 0 value, the origin, so I can show my negatives on the left and my positives on the right. I want all the values that are less than -70. Here's -70, but I don't want -70. I don't have an equal sign. So I'm going to keep it open, and I want all the x values that are less than. But I want also all the x values that are greater than 42. Here's 42. I don't want 42. I don't have an equal under, but I want all the values that are greater than. So I knew from the beginning that that's the kind of graph we were going to get because we had a greater than case. So there we go. Okay. Double check my arithmetic in case I made any mistakes and let me know, but I'm pretty certain that that's what your solution will be. Okay. I love when students catch my mistakes and they come and tell me. I am very, very glad. It shows me that you are watching these videos. The last question is question number 13. I must isolate, first step, isolate the absolute value. There's some sort of a quantity inside. My goal is to always remind myself, isolate the absolute value. Okay? It's okay to talk to yourself when you're solving problems, kind of like tutoring yourself. So I must isolate. I got to use PEMDAS backwards, the order of operations. So I'm going to add a 3 to both sides. Now on this side, a -3 and a +3 is 0. So I do have my absolute value all by itself, the absolute value of the quantity x minus 1. I just added, so it's less than or equal to a -5 plus a 3 is a -2. I am ready to use the definition, but one thing, it's a little side note, is the absolute value of any value, doesn't matter what it is, any value, the absolute value of any value is always a positive answer, is always a positive answer. The absolute value of -10 is a positive 10. The absolute value of -100 is 100. So the absolute value of any value will never, ever, ever be negative or less than a negative. So the absolute value of this is going to come out a positive number. And a positive number is never, never less than a negative number. That is never a case. So this is a no solution case, all right? Because we know, just by common sense of absolute value, is talking about distance, and we cannot have a negative distance at all. So the positive never equal, or is less, or is greater, or is less, or is equal to a negative, okay? So it's just those little details you have to pay attention as you're solving, besides isolating, and that is the solution for number 13. Okay, so I hope you can watch this video. Let me know if I made any mistakes. I appreciate you guys watching it and working on this homework. Good luck.